These videos are about the examples in the section in the textbook on trigonometry. Question 13. A box has a rectangular base that measures 30 mm by 60 mm. So that's 30 mm there, 60 mm there. The front of the box is 40 mm high and the rear of the box is 60 mm high. So calculate the length of the line that joins points A and D. So that's point A here to point D here. It's this line that's in 3 dimensions. So we've got the x-axis which is coming out of the page, which is red. We've got the y-axis which runs along the page, which is blue, and we've got the z-axis which is vertical and is green. And we're interested in this cyan line that goes from A to D. So what we need to calculate is the distance from A to B. Well, A to B is in the rectangle. It has got side lengths 30 and 60. So to calculate the distance between A and B is equal to the square root of 30 squared, which is this distance here, plus 60 squared, which is this distance here. So we can put that into the calculator and we'll get 30 squared plus 60 squared equals, and I'm actually going to put that into memory. So I'll put that into the memory as the squared value, but we'll take the square root of it, which is 67.08. So that is equal to 67.08, but actually we're going to want the square for the next calculation. So what we're actually looking for is the length AD. Well, AD is equal to BD squared plus AB squared. So we've got AB there, but we've stored AB squared in the calculator's memory. So AD is equal to the square root of I'm going to say 67 squared, but we know it. We know this value to a higher degree of precision, plus 60 squared. So we're going to put that into the calculator. Let's just move that up a bit. So getting the calculator, we've got 67 squared in the memory, so I can do a memory recall. That's 67 point whatever the decimal places were squared, plus 60 squared equals, and then we want the square root of those, which is 90. The length of AD is 90. So we'll put that into baseline. The length of AD is 90. And are we right? Yes, we are. Question 14. Find the length of the line that joins the points B and C. B and C. So this is a similar calculation to the previous one. We're using the same diagonal of the base, only instead of having 60 squared, this time we're going to have 40 squared. So we can just put that straight into the calculator. So we'll clear this answer and we're going to get memory recall, which is the diagonal squared, plus 40 squared equals, and then we want the square root of that, which is going to be 78.1. So 78.1, and are we right? Yes, we are. Question 15. Calculate the angle BAD, giving your answer in degrees. So the angle BAD is in this triangle here. We've calculated AB, we've calculated AD, and we know BD. So we could use the arc sine or the arc cosine or the arc tangent. I'm going to use the arc tangent. Now, the length AB is 67, the length BD is 60, so they're almost the same, which means that this angle here is going to be a little bit less than 45 degrees. Okay, so we're going to put that into the calculator. So we need to make sure that we're in degrees, not radians. So we're going to have 60 divided by memory recall, and we want the square root of that, 0.89, that's about what we'd expect, and then we want the trig second tangent, so that's the arc tangent, and 41.81 is a little bit less than 45, so we're probably right. So 41.81, 41.81, and are we right? Yes, we are. And then finally we need to find the angle ABC in radians. So the angle ABC, this was 67, this was 40, so this is going to be a smaller angle than the previous one. So we're expecting this to be in degrees about 30 degrees, or pi over 6. Pi is equal to 3.14, call that 3. 3 divided by 6 is going to be about 0.5 radians. So we'll go back to the calculator, we'll remember to put our value in radians, then it's going to be 40 divided by memory recall square root equals, and then we want the arc tangent of that, which is around the value we expected of about 0.5, so 0.54, we'll put that into baseline, 0.54, and are we right? Yes, we are.